Okay, good afternoon, everybody. I'm glad there's still a few people showing up because there's been a lot of talks about microservices today and yesterday, I guess. I hope you can all hear me in the back too and stuff like that, blah, blah, blah. Tested it. Okay, let's go. So, this is yet another talk about microservices. As you might expect, it's one of the most popular subjects we can talk about at conferences these days. So we do. A lot of people do it. This is originally a 90-minute talk, which I designed for a conference that has 90-minute slots. This only has a 40-minute slot. So I removed a bunch of the stuff from the deck, and I hope it will fit 40 minutes. If it doesn't, I'm already apologizing beforehand, and I hope you will endure me if I go over time. So, first of all, let me briefly introduce myself. My name is Sander. I used to work for a company called Capgemini for a lot of years. I went independent last year, and I became the CTO of an insurance company in the meantime. I'm basically a dad, so I have 3 kids. That takes most of my time, and in my free time, I do work, stuff like that. I'm basically a programmer. I get to do some agile stuff as well, and some architecture, stuff like that. This is my Twitter handle, if you feel the need to tweet about this stuff. My website is also on there, so that's about it. Wrote a bunch of books. Unfortunately, this one is in Dutch. So if you're not from the Netherlands or Belgium, you probably don't know how to read this, except if you're a linguist or stuff like that. This is the same book in German, by the way, and there's a US edition as well. It has an additional chapter, blah, blah, blah. This was the sales pitch, right? So I'm stopping doing that right now. To give you a clue about what I do, I was in a project at a social security agency in the Netherlands, and they were building a website on top of these huge COBOL installations a while ago. And for some reason, they didn't want people to leave the page they were editing, so you weren't able to push to close the browser, to close your PC, actually, if they wanted to, or move to another tab, or type in another URL, stuff like that you couldn't do. So I created a bunch of JavaScript to sort of test whether I could actually prevent that from happening. And as you started testing, you write an alert, right? And at that particular point in time, the project manager came to me. He said, "Can I do a demo at the client's CEO?" And I said, "You can probably do that, but there's some untested code in there. So please watch out for that." An hour later, he sent me this screen grab. And he said, I sure hope you don't have any more of this untested code in there, right? And so this is basically what I do. I write code. So before I start, I am an old guy, right? I'm probably older than most of you in the room, which is terrible, by the way. So I feel old. I'm feeling like a granddad or something, which I'm not. So I have to talk about monoliths a little bit, right? So who of you has got I'm not sure what sort of companies you guys work for. I work for an insurance company, so we have huge monolithical systems, right? To give you an idea, we have a mainframe that has applications running at least 12 million lines of code. We have Java applications that have like 10 million lines of code. Not the best Java code I've ever seen, but then again, it's Java, so who cares anyway? Who of you has a code base of more than, let's say, 1 million lines of code? Oh, that's quite a few. 2 million lines of code. Okay. 22 million. Sorry. And that's hard, right? Because the thing is with these monolithical applications is, it is impossible, in the end, to keep maintaining them. Basically because a lot of things. Well, it has some advantages as well, right? It usually is a single code base written in a single language. Some legacy language like COBOL, for instance, or C++, or Java, or whatever languages you have that are legacy, basically, now. So it has usually got a single architecture, which is usually, well, you can literally not see the architecture through the code anymore if it has been maintained for years and years and years and years. So basically, even though you might have a team that still supports that stuff, there's some issues with that as well. For instance, if you have a mainframe with COBOL on it that's sort of working in these black and green screens that you might have, and you want to build a mobile application on top of that, or a web application on top of that, it's usually pretty hard, right? So that means that changing technology or evolving in technology becomes pretty hard. And moreover, people who write COBOL, they're even older than I am, right? Like 10 to 15 years older, they'll retire in the end. Lots of insurance companies, government agencies, they are worried with this. Because if their programmers leave, how are they going to maintain this code? Now, the problem with all that code basically comes down to one thing. It's called dependencies. Dependencies in code will kill you. You've probably all seen the issue with these 11 lines of JavaScript code that some developer took out of open source, and then basically the whole internet collapsed, right? 11 lines of code, right? That's an idiotic dependency. But if you go to these big systems that are really, really hard to maintain, it's usually these dependencies. Now, this picture I've got up here is from a previous client of mine. This is a systems landscape, by the way. This is not classes in a class diagram. Every rectangle here is a system, right? The biggest one of all is the pink one here. It's called SAP CRM. If you ever see these 3 letters here, SAP, leave the company. Run, right? So just to give you an idea, just every single rectangle is a system. This little system here has a database with 142,000 tables in it. Yeah, 142,000 tables, not records, tables. And this thing is just their customer service department. Right? This is the companies that are out there that are running huge amounts of software. If you upload a picture for your card, for your subscription card with this company, it goes at least through 12 of these systems. Now imagine that if you would be, let's say you write user stories, right? Who loves user stories? Oh, it's only a few. Suckers. Anyway, so let's say you write a user story for this. So as a client, as a subscriber, I want to upload my picture so it can be printed on my card, right? And it goes to 12 of these systems. How stuck will you be, right? This is terrible. So this is the trouble with monoliths, right? And I'll give you a brief history over time, because I'm an old guy. I've been programming for most of my life, like 35 years already. I've seen lots of programming languages. I started off with this guy. Do you know what this is? This is a Commodore 64. It rules. Who still has one? Cool. That's cool. Like 38,000 bytes free to write your program in, right? And we could do that. They wrote beautiful games in that. So then I went into professional life, and we did client-server. That was a nice era. We could write in Power Builder or in Visual Basic. I know that's not a language, it's an anomaly, but anyway, people write in that. And some of the code was on the database server, and some of the code was in executables. Now, I know you don't know what an executable is, but it used to be something in computer science that runs on a machine and stuff like that. And every time we changed the code around, we had to go out and deploy everything with a floppy disk. Well, none of you knows what a floppy disk is anyway, but we did it like there was no internet back then, right? It didn't exist. There was no HTTP. So this was an era that we built applications on the desktop, and as soon as they grew and grew and grew, the dependencies got bigger, and we copied code around, because Control-C, Control-V was my best friend. And we did that for a while, and they all broke down when these applications got bigger and bigger. And then these large companies moved into something called component-based development. I don't know if you knows what it is anyway, because this is old stuff, right? This is early 90s or something. And we used to have object request brokers, some sort of very complex middleware to tie applications together, right? So we could reuse stuff that is in another application. Sounds interesting, except that it was way too complicated, and big companies made loads of money on this, and it just became too complicated. Again, too complicated. So we moved into service-oriented architecture. And we had enterprise service buses in the middle. And everything could connect, basically using SOAP and XML and HTTP to this enterprise service bus, and it ranged your processes. Everybody happy. Did somebody do this? Did you like it? You did? Oh, you're in for a shock then. No, it was quite all right. I've seen this working, except that it took us 3 years to get it running, right? So it, again, still was too complex. And then we moved on again, and we moved into, let's say, we're now in this cupcake area, right? We used to write spaghetti code on the client, and then we split it up into bigger parts, like the systems landscape I've shown you. And now we're moving into the cupcake area, right? There's only cupcakes. There's nothing in between. There's no enterprise service bus. There's no object request broker, stuff like that, to arrange everything. So you have to figure out everything yourself. Now, this is where we are now, right? And to the old geezers like me, it sounds like, oh, this might be mac and cheese. You have all these little macaroni parts, and there's some cheese sauce on it. Nobody knows what's in the cheese sauce or how to get it running, stuff like that. And if you're old like me, it sounds a bit like Groundhog Day. Have you seen Groundhog Day? Go see it again tomorrow, and the day after, and the day after, and the day, etc. So it's, yeah, we've seen it, we've been there, stuff like that. Yada, yada, we're the old guys, we know everything, and we do. And so it's a bit of a hype, right? Everything you see these days it's either DevOps or continuous delivery or microservices. That's about it. If you're not doing one of those three, you're not hip anymore, right? I don't care how many JavaScript frameworks you know. If you don't do one of these three, you're not it. They change every day anyway. So basically, where does the hype sit? Well, I started off doing this like 3.5 years ago, and I was working on it. And back then, the posts were a bit like this, right? Yeah, microservices, great stuff for creating scalability and whatever you have, and deployability, and yeah, it's all new and it's great. And then again, people were wondering, what on earth? That's the nice way to put this. What on earth is a microservice anyway, right? Is this like, in the previous one, it said like 10 to 100 lines of code. That is pretty small, actually. Doesn't have much value to put it in lines of code anyway. So, and this one says maybe 5,000 lines of code and exposed via JSON over HTTP protocol, which has at most 5 endpoints. So if you have more than 5 endpoints, you're not a microservice. I don't really care, by the way, if you're a microservice anyway. So people started writing about it. Of course, Martin Fowler has a lot to say about this stuff, and ThoughtWorks does have a lot to say about this, so go see their stuff. People start writing books about it. Sam Newman wrote the first book on microservices. It was published not even 2 years ago, right? There's even conferences about this stuff. Right? There's actually, this one was sold out within a week. So it's pretty popular stuff, right? Even in Eastern Europe. So this is Russian. It says like, microservices architecture. Cool, right? So it's going everywhere. It is everywhere, right? And if you look at hypes, you have to know this graph. Who of you has never seen this thing? This is the Gartner hype cycle. This is the best graph in all of IT, to be quite honest. So what does it do? Well, it sort of predicts what happens to technologies. Any technology whatsoever, by the way. But you can also use this in very different areas. But this one works well for IT. So basically, when a new hype comes along, so let's say microservices, it's being hyped a lot. So you read about it on the internet, loads of stuff, all this introductory stuff, all this hallelujah stuff like, we should all do microservices, yay! And then people start doing it, right? And once they start doing it, you get to the peak of inflated expectations. That is the cool part. That's when people start trying it out, and they realize it's not that easy. It's much more complicated than you thought it would be. And then people are saying, this sucks, right? Microservices suck. You will see those posts coming out, and they are already coming out. So that's a signal that we have moved into the trough of disillusionment. Right? People saying, this is not the thing. And they'll jump on the next bandwagon. I haven't really figured out what that one is, but it might be DevOps or continuous deployment or whatever you want to do. So, but in the end, you will see that people will start using a particular technology and they'll find the right use for that. Now, microservices is somewhere here. Maybe it's even over the top a little bit already being hyped and people writing against it. Now, it doesn't work. It doesn't work if you do software integration stuff like that, right? So people who are now doing it are the early adopters. Now, that for me is a strange thing because I work for an insurance company. Now, insurance companies are very well known for avoiding risk. That's why they're an insurance company, right? And they also do that in IT. So you get to these organizations and they're like, yeah, we're building these really big systems that should do everything in the kitchen sink. And I'm like, nah, maybe that's not a good idea for an architecture, right? So let's see the benefits of this stuff. I'll do this briefly because you might have seen all of this, right? I'll show you a short definition. This is Martin Fowler's definitions. They're very different definitions. So the thing is, there is no definition for microservices yet. There's different definitions, and they sort of all do the same, and they focus a lot on technology and infrastructure, and they focus very little about when is something a microservice, how to design this stuff, right? So we had to figure that out ourselves. So basically, this definition is saying microservices are an architectural style, right? They have to do with how you architect your software, and it is changing. It will change the way you write software. It will change the way you deploy software. It will change the way you test stuff. And it has some benefits and some drawbacks. So basically, Martin Fowler says, you're building a single application as a suite of small services. Could be 50, could be 100, could be 200, depending on the granularity of that stuff. So we decided, as an example, this insurance company, that we're not only building these small components that deliver small services, we're also building very small applications. Most of the applications that we have are just implementing a single business process, a very small elementary business process. So they have like 3 to 5 pages at most. And that means all of this stuff communicates with lightweight mechanisms. Most people use HTTP and REST and JSON. Who doesn't, by the way? Does anybody still use SOAP? Well, in the shower, of course, but not anywhere else, right? It's so gone off the radar, right, SOAP? It doesn't exist anymore. But the thing with HTTP is, if your server isn't there, and you're going to retry sending your message out, how do you know it succeeds? What if you have a whole bunch of messages, and they should be in the same thing, which people used to call a transaction, but that's a dirty word these days, right? So you group together a bunch of actions. What if the first one fails? Or what if the fourth one fails? Those are typically application integration problems. You don't solve them with microservices, to be quite honest. You get more of them. So if you have one client and one database, there's one call, right? Well, you can sort of connect that. But if you have 100 services that are all running together to sort of implement a single business process, you have the same issues, except in a very large context, which makes it even more difficult, right? So basically, any one of these microservices is built around, as Martin Fowler puts it, some business capabilities. To me, that is where the interesting part is. It's about, what does a microservice actually do? How small is it? Does size really matter? Oh, that's a tough question. Let's move on a bit. And he says they're independently deployable. Now, that's a cool thing, right? Because being independently deployable means you can scale up a bit more easily. And that's a good thing, right? So, and then he says, there's a minimum of centralized management. So there you go for your ESB, your enterprise service bus. There is no enterprise service bus anymore in microservices. People nowadays consider enterprise services buses to be a bad practice. And it isn't always a bad practice, by the way. So I'm not promoting it, but I'm not against it either, right? So, and it used different programming languages. Now that's the tough part. So this insurance company I work for has Java programmers, right? They write Java. They don't know how to write other stuff. They don't know how to write Node.js. They don't know how to write C#. They don't know how to write Scala or F# or Ruby or Python or whatever you might have. They'll just write Java, right? So we're still a Java shop. So yes, because they are independently deployable and they communicate over HTTP usually, that basically means that yes, you can write every component, every service in a different language. Does it make sense? It doesn't always. Because you have to also be able to deploy all this stuff, right? So if I'm deploying a C# service on one side and a Java service on the other side, I have 2 full stacks. Sort of. Well, you can sort of mix it together a bit better now. But so it's not always a good thing. Which is a good thing, by the way, is the last thing. It's called using different data storage technologies, right? This company used to be all on DB2. It is a SQL database. Now, in this audience, I might have to explain what a SQL database is. I'm not going to do that, by the way. But we have moved, and we have seen that for different reasons, you can use different storage mechanisms, and it works quite nice. Documents, for instance, you might be able to store them on the file system, where other stuff that has a strong hierarchy might be even stored in a SQL database. Yes, they're still around. And you might store other stuff, what is sort of more flexible, maybe in a document database. And we do that. And yes, microservices helps you to get to the right storage mechanism for the right problem. Now, some of the benefits is basically, if you have to scale up a monolith, you're doomed. Because the only thing you can do is pull up more instances of the same huge application, which consumes huge amounts of memory and data and disk and whatever they do, right? But if you would be able to split that thing up into smaller parts, you could say, you know what, I'm going to run these things on different machines, in different processes, maybe in different containers. By the way, my guess would be, first make sure your architecture's right. Make sure that you can actually do this stuff before you start investigating all this container stuff. It's not always worth it to do that immediately, right? So, yes, this is a much more scalable architecture. And the same goes for persistency, right? A single huge application usually has a single huge database. One of my clients has a database, they're a small company, right? They have a database of 650 tables. To them, that's huge. If you look at the data model for this particular thing, it's just a big black box. And you have to zoom in really deep before you can even see some detail. Now that is an issue, right? But if you could say, you know what, I have all these little different components, and they can use different storage mechanisms. It also allows you to be able to say that, you know what, every microservice, every component has its own database. We do that, by the way. Every one of our components has its own database. That's an interesting thought, right? So yes, it has a bunch of good stuff is about microservices. It's like, it's really scalable. There's some decentralized governance. There's no need, per definition, to have this enterprise service bus in the middle. So yes, you can use different programming languages and different data storage technologies. And yes, it can be very high performant. It also has some drawbacks. There's lots of stuff that you have to consider before you start doing this. You have to figure out how to deal with, so what is actually microservices? How do you deal with REST APIs? How do you make them RESTful? As a small example, how do you design and how do you decide what's in a particular service or component? What does it do, actually? Or how do I test this stuff? Testing a microservices architecture is way different than testing traditionally. Basically, you have to test everything automatically. And we do that. So there's lots of stuff to consider. And then there's lots of people talking about this stuff, right? It's like, this comes from the ThoughtWorks blog, and they say, well, you know what? We aren't arguing that we are certain, which is a strange sentence, by the way, that this is the future of software architectures. So yes, it is. I agree, too. And then there's other people like Simon Brown who says, well, basically, if you're unable to build good monolithical software with good split up into good modules and good namespaces and whatever you might have, you won't be able to do this because it gets more complicated, because the dependencies, although they're much more visible, tend to become more complex as well. And then Sam Newman says, the author of the book, he says, you know what, doing Brownfield is much easier than Greenfield. Duh. Oh, it's a nice quote, actually. But so he says, basically, if you're trying to cut off chunks from a very large code base, that is easier to do than rebuild everything from new. But if you have a mainframe, like the insurance company we work for, that you want to switch off, literally, you cannot chunk off pieces of that. You have to do it all new again. And that is a big investment, actually. And then Martin Fowler, of course, agreed with that. And then Stefan Tilkov, who's German, says, don't start with the monolith when your goal is a microservices architecture. He's German, right? So there's lots of different opinions. So the question is, should you really go this way? Is this the new good thing? Or is it just the next highway to hell? Now, that is the question, right? And we started answering that like 2.5 years ago. The company I work for has a mainframe. They want to get rid of the mainframe. It costs around €1 million per year to keep it running. There's code in that which is written in this particular language. Nobody knows, except for Tom, who knows what this is. This is ideal, right, Tom? Yeah, it's ideal. It's sort of COBOL on steroids, sort of. Looks horrible, right? It has some Dutch in it as well. And the thing is, the people who are able to program this, they age, just like we do. They age, right? And they will eventually retire. So they look a bit like this, right? They're called the dinosaurs in the company, right? It gives you an idea about what kind of people these are. And the thing is, once they retire, there's no way that we can actually maintain this stuff. So they had to move away. They had to move towards Java. Now, I'm not really sure what you're better off, right? Is this or this? If you go to a Java conference, it's mandatory to have a beard and glasses, right? So I bought glasses just to be able to go to Java conferences. So that's a good thing. So the question is, now what? You've seen Nemo, right? Go see this if you haven't seen this. They escaped from the fish tank, and now they're in the sea in plastic bags. And then somebody says, okay, now what? This was the point that we were at. And we had to figure out what to do. So basically, the first thing I said is, we have to start learning. And we have to allow ourselves to learn new stuff. I read a quote yesterday that said, the first thing you need to know if you want to become a good software engineer is learn how to learn. I thought that was a very deep thought. I read that yesterday, but I was drinking heavily, so maybe it wasn't as deep as I think it was. So anyway, so we started learning this stuff. Now, the problem with microservices is it's not just one thing. So if you've seen the talk right before me, that was all about infrastructure and about mesos and stuff like that, and it's a very different talk than this one. There's also stuff you have to consider about how to test stuff. So there's all new test technologies in there. There's all new design technology, design techniques that you need to use. So it's lots more than just saying, hey, we're doing microservices and we're fine. That doesn't exist. So it's lots of stuff. So what did we learn? So this is part of my team. Well, it looks good, right? Well, not everybody, but anyway. So, the first thing we said is we have to allow our architecture, our software architecture, to grow, to evolve over time. Because once we realized that we didn't know everything, we didn't know lots of things, by the way, which we now sort of know, we had to say the software architecture will evolve. So basically what we did is we set up some guiding principles, just a few actually. And I wrote them down into a presentation, we did the talk, and we said, okay, let's start with this stuff. And we figured out that our client, which is the CEO of this insurance company, basically thinks in business processes. So we better make sure that we implement business processes. And we said, you know what, we're going to move away from stuff like writing documentation in Word documents. Now, you might think that modeling, especially if you use UML techniques, is old-fashioned. It isn't. It's still very, very, very useful. So we use a modeling tool to store all our models, and I'll show you some of them if I do have the time. I'm not really sure where I'm still quite okay. And we said, you know what? We are starting to build small applications and small components as well. All of them have in their core, in their heart, a bounded context. And that is a key aspect to what I think is getting to the right granularity for microservices. So we wrote down a very straightforward, simple architecture. So our applications look like this. This is all we have on architecture. But it is a very clear picture. And if you go through the code bases of our small applications, and the same for components, except that they have a service interface instead of a user interface, they have the same structure, right? The way we write the code to that changed over time. We're now writing much more functional code than we did like 3 months ago. If I look at my own code that I wrote like 4 months ago, I'm like, that's terrible, right? Let's rewrite that. Well, you can actually do that, right? So we're now able basically to write a new component in a day or two, including all the tests and stuff like that. And the thing is, even though the code has evolved, you can still recognize this very simple, straightforward architecture and the patterns we used in the code base. It's still the same. It has evolved, but the structure is still the same. And that's a good thing if you do microservices, because your team will change and evolve over time. Well, people will leave, people will come in, and you have to understand how it works. So that's one of the things we learned. The next thing is that we also learned that it's a bad thing just to start writing code. To you, that might sound a bit old-fashioned, but the thing is, it's not a bad thing to think about what you do before you start doing it. I'm not saying go out and write the whole design and do that for about 1.5 years and then try to write some code, because that will fail for sure. But think a little bit about what you do. We had to figure out how to work with that. Now, this to me is the most important, well, not this one. This is another implementation of bounded context, but this one is actually the one pattern that will help you do microservices the best. A bounded context, I can better explain it, because who of you has not read this book? Go out, buy this book, read it tomorrow, or today even. Well, after my talk then. So I'll explain a little bit about the bottlenecks. Let's say this is your huge domain model or data model, or whatever you might call it. The problem with this model is, again, it's dependencies, right? The problem is the product class in there. Because basically, it lives in 2 different environments. It lives in something we restock and we buy our stock back from vendors and stuff like that. And it lives in the part where we sell stuff. Now, if you only have one product thing living in there, it has to deal with responsibilities from both sides. It has to deal with data from both sides. Now, the thing is, that makes this thing very central to what you do. And that makes it impossible to go into a different direction with the part on the left without changing the part on the right. Now, this is what is killing your software, this particular pattern. So the thing is, you can split this up. Let's say you are able to say, I'm going to do the product thing that belongs to, I should go to that side, that belongs to buying stuff as a company, and I can do the properties and the state and it belongs with that and the responsibilities on one side, and I'm going to split it from the rest of the product, which basically sits in how we sell stuff. So it doesn't have all these shared responsibilities anymore. The only thing you need to do is make sure that there's some sort of very thin line between these two. Now, if you do this, so if you split up your domain or your data model or whatever you do into smaller contexts, that basically allows you to let this thing grow in that direction and let that thing go in that direction without having all the bother of all these dependencies. So this was for us the central pattern that we use to design our components and our applications. So every one of our components and every one of our applications has a model like this. This is a domain model, just in a class diagram in UML. And it's in Dutch, I'm sorry about that. This is a very Dutch company. And it has 4 domain objects. So this is the core, the heart of one of our components. That is it, right? We don't have to reason about 22,000 tables in there or entities or whatever you might have, just 4. You can manage that, right? So that basically makes your microservices components and applications as well easier to write. Now, think about using bounded context for the rest of your life. Make sure you have domain models to reason about anyway, because that is, to me, the most important paradigm in software development. And then we have to figure out resources, stuff like, how do you write RESTful APIs? We didn't know that 3 years ago. We hadn't got a clue, so we started learning that. And we realized soon enough that we had to create some model of that as well, because in my project, there's devs, there's infrastructure people, there's testers, there's analysts, there's product owners, and they all have to understand. They have to have this common idea about what the API is doing. So this is a way we figured out how to model that. There might be better solutions. My guess would be that in the next coming years, people will find easier solutions to do this. Still, this is not a bad idea to have a model like this. So basically it says you come in at what verklaring in Dutch means statement in English. So you come into the statements resource and you can do a get and a post to that. If you add the idea to it, you can get a single statement and you can get the results from that and you can put a statement in here. So this basically lays out the API for this particular component. So basically our testers can write their tests to this diagram, actually, and the developers can write the code to this diagram, and the analysts can just write the diagram, right? They have to do something as well, right? So this is a way we figured out how to do this. Now, the next thing was actually to figure out how to work with REST and HTTP. For you who are native to HTTP and REST, remember, I'm an old guy, right? I didn't really figure out how to do this. Stuff like, what if you do a get on a collection? What do you pass back when the collection is empty? And people might say, oh, it might be a 404, which it isn't. Because getting back an empty collection is quite good as well. It just says there's no results to what you're querying. Stuff like that. You have to figure out all these HTTP status code and how to create RESTful APIs. To me, I was fairly new to this stuff. It wasn't really painful, but it was harder to do. And we figured out that we need to structure that out. So we created a small API that basically sits in the middle between our applications and our components that takes care of all the RESTful stuff, right? It does serialization, deserialization, to and from JSON. It makes sure that the right status codes are in your message, stuff like that, right? They just do that. And we figured out how to use these status codes. So I created a cheat sheet for that. It's basically very simple to work with your HTTP status code. This one is the most useful one. If you pass back a 400, that means you created the wrong query. And if it's a 500, that means we as a component have fucked up, basically. So this is a very easy thing to use, right? Just start from here and go read all the documentation. And the problem is, it is not standardized what you pass back. So you have to figure it out, and you have to agree on that with all the developers in your team and all the testers and stuff like that, that if I do this, I get back a 201 or a 203 or a 204 or a 309 or whatever you might have, right? So make sure you agree on that before you start doing this. And then there's Postel's Law. Postel's Law says, be conservative in what you send, as a component or as a client, and you have to be liberal in what you get back, what you allow to get back. And the thing is, if I have a component that sends out stuff, let's say I'm sending out the 751100 box, and it has a bunch of components in there, and my client says, well, basically, I expected this. you still have to make sure that it works, right? You have to figure out how to deal with all these other parts. And on the other hand, what if I only needed this? I only need a very small part of what you're sending out. That means I have to figure out a way to throw it all out, all the other stuff, without crashing. Now, all this kind of stuff you have to figure out, right? So it's not as easy as it looks. And then there's testing. Is anybody of you a tester? Good. Well, basically, testers don't go to developer conferences, and I think that's a shame. And it's basically a shame that developers don't go to tester conference, even though they're usually boring. Is this on video? This was my last talk at a testing conference, I guess. And no. So basically, the thing we said is, we are moving into, let's call it continuous delivery. My boss thinks it's continuous deployment, but she wants to move even further than I do. So that basically means, if something is wrong, we don't go back. We don't patch stuff. We just move forward. We'll just repair the bug in the trunk and just ship it out again. Now, the thing is, what you have to realize is that this is a complex architecture if you start working with microservices. That means testing becomes way harder. Testing a single component is easy, right? It's just testing the API. But testing them all together, integrated stuff, regression tests and stuff like that, becomes way harder. So you have to do it all automated because the landscape is so big that you can never run all these tests by hand. That basically means that we had to, well, even though you might think, so are you into exploratory testing as a tester? Yeah, sometimes it's a good answer, right? We do it too. Because if I write some code, the tester's literally sitting next to me and saying to him, hey, Mike, could you please check out this stuff? And he's like, oh, it breaks. Please repair that. And I'm repairing that. But as soon as he says, it's OK, then he starts writing his tests again in code. So they write Java as well in our company. That makes it very hard for us to find the right testers, by the way. And we write everything in code. All our tests are run automatically. And they run, well, at this point in time, they run every night. We deploy every night, and then we run all our tests. And there's sort of a life cycle in there. The tests run for about an hour and a half these days. And we have to figure out a small set of that we can run on every check-in that we actually want, because you want to get the feedback as fast as possible. So if you're doing microservices, you want to be able to ensure that all your unit tests run, right? And we write them, for instance, so this is a Java environment. We write them in JUnit. We use Mockito, Hemcrest, stuff like that to write our unit tests. If they fail, we go back immediately. And then we sort of check it in, and then the tests run, all the unit tests run for all of the components and stuff like that. We run Sonar over it to make sure that the cyclomatic complexity of stuff is not getting too high. And then again, it's deployed again, and we test all the contracts of the components, and then it's deployed again, and we test all the scenarios using stuff like JBA, Selenium, and we run all the scenarios automatically. After the point in time that the tester and I work together, sit next together, work on the code, there is no manual testing anymore, because the landscape will get too complex to be able to do this. So stop doing all these manual tests, except for the small collaboration within your team, right? That's one of the things we noticed. So the last thing I want to tell you, because I only have like 2 or 3 minutes, only 1 minute, which means I'll go 5 minutes overtime, so I'm keeping you from lunch for 5 minutes, but that's okay, because the queue will disappear as soon as you leave the room, right? This is the last thing I want to tell you. So this is my Twitter account. It's a picture I took a while ago. So it looks quite nice, right? It's using Bootstrap and stuff, and it has a nice UI to it. Now the thing is, if you look at traditional software development projects, they might take 2 years before they go into production for the first time, right? You might have seen these projects. People do them. Right? They have these waterfall projects, and they start off on writing some requirements, and in the end, they'll put it out, and nobody knows what it is anymore. If Twitter would have done that, they would have like 5 users these days, right? And they have got like 500 million or something. So what they did is they put out the first version. I'm going to show you the first version. This was the very first version of Twitter, right? And it has evolved over time. If you're using Gmail, for instance, it evolves about every day. You don't see the differences because they're very, very small, right? Now, that's the point I'm trying to make, because if you are doing this, you can go into a very different model of doing projects. Now, I don't like projects, because they have this like fixed scope and fixed amount of money that you have and fixed amount of time that you have to do this stuff. And if it doesn't work, they'll kill you. And the project manager gets away with a big bonus, usually. And you're to blame, stuff like that. You don't want that, right? So what you could do And microservices allow you to move into this direction, is saying, for every feature that we can build, every next feature that we can build, we could say, you know what, we're building the easy version. We're building the skateboard version. And you can say to the client, dear client, this is the next feature that we'll pick up. Or you let him decide, by the way. And you can say, you know what, for a little amount of money, we can build the skateboard features. You can go from A to B, just as you want it. That's your requirement, right? You can do it in a more luxury version, but it costs you more money. Well, quite usually, the client will say, oh, please build me the skateboard version. That's OK. And once it's done, you can say, oh, give me the next feature. And we're going to ask you the same question. Do you want us to build the skateboard version or the very luxury version? Now, in the end, you will get a product, which is called the minimal viable product, that implements all the requirements that were needed to go out into production. But there's like 18 scooters, 18 skateboards in there, 2 bicycles, and 1 car. In a traditional project, that would be like 19 cars implemented. Way more expensive, and it takes way longer to get out there, right? So my guess is, this is much easier to do. So you move from, let's say, a single project, and the rest of it is maintenance. You can say, I'm only going to build this very small set that we can actually need to go into production. And the rest of it, we might call it maintenance. And that's stuff that we call continuous delivery. Now, that is way cooler, right? And the thing is, if you move into continuous delivery, you have to read Jess's book. That is the book in this particular field. And he basically defines it as, you know what, every change to the system is releasable. That means you have to do all these tests, right? Automatically. And that we can release any version at the push of a button. Now, the problem is that that thing will put you into the hands of the people who run the software. It's the ops guy. Who of you is an ops guy, by the way, before I start bashing on you guys? The thing is, I largely agree. I think most of this stuff has to be done by the teams themselves, right? Once these components and these applications are into production, you have to make sure that they keep running. It's your responsibility. But the thing is, you move into this DevOps field, and I'm a developer, right? I haven't got a clue about how to work with infrastructure, right? And I'm talking to these guys. I'm actually the product owner of our operations team, and they talk in different things than we do as developers. And we have to try to match that stuff, and that is not as easy as I thought it would be. So, small retrospective. I'm not going over time really big this time. So the thing is, microservices is an umbrella, right? It's not one technology, it's not one technique, it's a whole bunch of stuff that you can just push under there and make sure that it works for you. Stuff like, oh, you know what, we have to do more modular design. We have to break stuff up into smaller parts. We have to release more often, basically because our time to market sucks. Stuff like that. So there's all kinds of benefits that you might consider if you might consider microservices the way to go to. But it's not easy, right? There's lots of stuff that you actually need to take care of. It takes a whole while before you get there. I was in a bar with Sam Newman a way back, and he said, it's basically a hockey stick model. He said, you have to invest a whole lot of time before you get there. It took us 1.5 years to get the first stuff into production. That is way longer than I thought it would be. But basically, we had to take a whole lot of additional stuff around that we need to take care of outside of creating the first functionality, right? So it takes a while before you get to be successful with microservices. And then again, look at the minimal viable product thing, because it will help you move around, change the organization in the way they feel about writing software. Usually, business people don't like us. And if you get to say, you know what, you want a button green and you want it on the right side, it'll be in production tomorrow. They'll start liking you, right? Except when you create bugs that also go into production because your tests fail and you haven't noticed that, as we had too. They don't like you after that, but they'll get too used to. So build minimal viable products. So basically my suggestion is stop doing projects, right? It's not necessary to move into, to go into in this traditional metaphor of projects, because it is not for software development. Software development is a different beast than building houses or building cars or whatever you do. Working in small stuff, in small batches, is much better suited for software development, and microservices will allow you to go there. Last but not least, allow your teams to learn, and always, always, always have fun in everything you do. That was it.